First thing we're going to do is look at, thank you, whether or not this set of ordered pairs is a function. So yesterday we talked about, for a function, do we look at the x's or the y's or both? Only the x's. Do we care about the y's at all? No, don't care about them. So I want you, super fat pen, sad day, underline the x's of each ordered pair. Here's real talk. Some of us forgot about ordered pairs, okay? So an ordered pair goes x comma y. Just like in the alphabet, x comes before y, so the x is the first number in the ordered pair, okay? So looking at just the x's, do any of the x's repeat? Yes. These threes right here repeat. So is this a function?
No.
Not a function. Now what we're adding today is domain and range. So here's what we do. We write a D and the little, what's colon? Is that what a colon? Is that a colon?
Yes.
The dot dot, whatever it is. Then we're going to make a fancy bracket. So let's do a fancy bracket tutorial for a second. I make like a backwards C and then like a little V-ish shape and then a backwards C again. Okay, I'm recording right now, so you guys good? Okay, so I'm just giving you, if you don't like doing fancy bracket, do a little like squiggly-ish thing. But you cannot make it as just a parentheses. That's the main thing. This has to be look different than just a parentheses. Kind of understand that? Now, for domain, we're going to list the x's from least to greatest. So we actually already underlined the x's. So we're going to list them from smallest to biggest. The smallest x I see is a 1, so I'm going to write a 1 and then a comma. The next highest I see is a 2, so I'm going to write a 2 and then a comma. And then remember we said, hey, the 3 is repeated. So the good news when we write the domain is we only have to write it one time. So even though it repeated, I just write it once. And then 4, bless you, bless you. Now we have to end our fancy bracket. So it's something like that. So you guys just wrote the domain of that function. Domain are the x values of the function. Now we're going to write the range. So I'm going to write an R with those dots and then open fancy bracket. Bless you. Same thing, we're going from least to greatest, but this time we're writing the y values. And so I'm looking at the y values. Some of them are negative. So negative 16 is the smallest. You notice how I'm putting a little slash through so I kind of know like I used it. It just helps me stay tracked. Next is negative 9. Then negative 4, then negative 1, and 2. And then close fancy brackets. So you guys just wrote the domain and the range of a function. Whoop, whoop. Pretty easy? Okay, so now we're going to look at number 2. Number 2 is called a mapping diagram. So just a quick review. These I call my little Indians, and these are the buffaloes. And so each Indian can shoot one arrow, and that's fair. But this guy decided to shoot 2 arrows. Is that fair? No. So is this number 2 a function? No, not a function. Remember though, if like 2 Indians shot the same buffalo, that's totally fair, right? So if we had 2 of them shoot like this guy, if this guy had shot over here, that would have been fair, but he can't shoot 2 arrows. Does that make sense? That's the only thing I want you to remember about those. Now we have to write the domain and range. So we write our D and our fancy bracket. these are the x values and these are the y values, and mappings are actually the absolute easiest for them because they have the x's and the y's separated for us. So least to greatest, it actually is in least to greatest for us. So we're literally writing -2, 1, 3, and 4.5, and then close our bracket. Then for the range, we're writing our y's in least to greatest. Are they in least to greatest for us? Yeah, so 1, 2, 3, 4, 5. So that's a little review over functions or not and domain and range if they're listed in ordered pairs like that. But now we're going to get to number 3, and it's a little bit different. Number 3 is a graph. So yay, when we see a graph, we need to hold up our pencil as our vertical line test, and we go beep from left to right. So if I go from left to right, is there ever a time that my pencil goes through more than one dot at a time? No. So yay, it's a function. Because it passed our vertical line test, or my little grocery scanner. Beep. I like to do it like that because I'm cool like that. So now we're doing domain and range, but this is hard. So this is called a continuous function because these are all the dots. There's no way we could list all the x's and all the y's because it includes every single teeny tiny fractional amount on this line. Like we would spend the rest of our entire life writing out those numbers if we sat in here and did that. So we have to write our domain and range a little different. So I want you to write a D with our little fancy bracket beginning. Okay, so here's how I want you to think about domain. Domain are like the doors at like Walmart or Target, like the doors that open like this. Yes? The sideways like open on their own. Okay, so this is what I always tell on my husband every year whenever I teach domain and range. My husband thinks he's real funny. He's like the kind of funny that like he doesn't say his jokes like super loud or like make a big deal of it. He just has these little like small little jokes, okay? So every time we walk in somewhere like that has the automatic doors, he always says, "Let me get that door for you." And then we walk in. And I'm just like, huh. Like every time. Okay, let me get this door for you. And then it like magically automatically opens every time. So I think about that every time I walk into a door, whether he's with me or not, because now I'm just like conditioned to think that. So I just want you to think about domain or like doors that automatically open side to side. So take your little hands and make them like doors and stick them on this graph. And let me get that door for you. So I'm going to open it side to side, right? So doors that open side to side. What's the farthest to the left that your door is going to open where it's going to be on this graph? So the farthest to the left is going to open. So draw a little line like this. And let's put a D on top. That's the farthest the door is going to open to the left. What's the farthest to the right is going to open is way over here. So we're going to draw this line. So our doors open from way over here to way over here. What X value did that line cross through right here? -3. What X value did this line for my domain cross through way over here, the positive one? 11. Okay, so the domain is every single number from -3 all the way to +11, including all the decimal numbers in between. So here's the way we write that. Leave a little space and write an X in the middle. The farthest to the left was -3, so that goes in that space. The farthest to the right was 11. And then we close our fancy brackets, but here's what we have to do. This is like an inequality. So we have to write this like everything greater than -3 and everything less than 11 is included. So all the x's greater than -3. So do you see how it looks like that, where it's open towards the x? And less than or equal to 11. This is a little bit more challenging, yes? So today's just our intro day. We'll be doing this a little bit more the next few days, okay? Yeah, it's not terrible. Most people, the thing they ask me is, do the alligators always stay the same? Kind of. These equal to's won't always be there. The reason that it's equal to is like it actually includes that point. It touches that point. That's why. Let's talk about range for a second. So if domain is side to side, because that's what the x's are, side to side, range are the y's, so we're going to go how high and how low. So I think about it like, I don't know, opening windows, like up and down, okay? So if we put our hands on here, what's the lowest that it's going to go? It's way, oops, way here. Is it a 4 or is it the 5? Yeah, it is. I think I just drew it weird. Do you think it's at the -4 right there? So put an R right here, and we're going to put -4. And then what's the highest that it goes? So we're going to put an R right there and a +9. So the range is everything from -4 to +9, all the numbers in between there. So we're going to have fancy brackets on the ends. What letter do you think is going to go in the middle?
Y.
Y. Because domain are the x's, range are the y's. We can actually go ahead and even make our alligators. And since it touches at those points, we are going to put them as underlined. And then the lowest was -4. The highest was +9. So again, if this one, number 3, is kind of confusing to you, it's okay. Today's just our intro into it. We'll do a lot more of these very, very soon. Last thing we're going to talk about today is number 4. It says, add another ordered pair to this relation that would make this not a function anymore. 10, 10? Like if we had the ordered pair 10, 10, that would make it not a relation. Why? Because those x values repeat. Are there like 1,000 million possibilities though? Yes, so like any x value, if you repeated that as the x value, that would make it not a function. Does the y matter at all? No. So like if we put something that had a -2 as the y, that doesn't matter that those repeat. It matters that the x value repeats. Okay? So all good on that? Okay.